Hello everyone, my name is Trang and I'm currently an intern with the Data Ops team at the AIRC Center. It's a pleasure to share my internship project with you today, supervised by Associate Professor Lê Hoàng Sơn. My project, the focus of my work has been on building a Proxmox HA cluster and virtual network lab setup. Over the next few minutes, I'll walk you through the key component and functionality we have implemented to create a resilient and highly available virtualization environment. Let's start by looking in this topology, cluster topology, as illustrated in the network diagram. Our infrastructure is centered around a 3-node Proxmox VE cluster comprising PV1, PV2, and PV3. These nodes are interconnected via core switching infrastructure, including an ATX 51 switch, which is keys for VLAN configuration, and a TP-Link switch. For external connectivity, a router MikroTik has provide one access. Now let's look at the key components that form this environment. Our internet and router setup ensure reliable connectivity. Core switching is vital and configure with trunk ports to manage our VLAN effectively. And a PFSense virtual machine handle network security and inter-VLAN routing. The host of this system is a Proxmox cluster, a 3-node setup utilizes Proxmox for robust cluster communication. And for data protect, we have a dedicated Proxmox backup server. These nodes host various VMs, including the critical PFSense VM for configure VLANs, NFF server VM for set storage, and we have a test VM for high availability strategy. For Proxmox high availability and features like line migration to function effectively, shared storage is fundamental requirement. In our project, we implement NFF Estimate Networks file system for this purpose. NFF provide a centralized storage location, making VM disk image accessible to all nodes in the cluster. This is crucial because if one Proxmox host fails, another node can take over and run in other VMs, run the affected VMs, as their disks are not tied to full physical machine. In our setup, we utilize a virtual machine initial host on node 2 to function as an NFF server. This VM exports a specific directory, which is then mounted by all Proxmox client nodes like PV1, PV2, and PV3. And the primary challenge with this VM-based NFF server is that NFF server VM still become a single point of failure. We can call it SBOF. If this VM or its host node were to crack, the entire set storage system would become unavailable, thereby undermining the HA benefit for all other VMs. So to address this critical single point of failure of our VM-based NFF server, we leverage the advanced capability of ZFS specialty its replication feature. Our core solution was to implement ZFS replication for the NFS server VM itself. So how it works? The virtual disk of our NFS server VM, which resides on the ZFS volume on its primary host, is PV2. It continuously replicate to a standby host on PV1. ZFS3 this efficiently by taking periodic snapshot of the ZFS volume and there incrementally sending only the data block that have trends in the last snapshot to the destination volume. This creates and maintains a near real-time consistent replica for the NFF server stick on standby node. In this diagram on the right illustrate NFF architecture where physics would teach from VDEV which is turned from a ZFS pool. From this pool we can create ZFS file system or as in our case from VM disk ZVOL. Our NFF server disk is ZVOL. If the primary NFF server or its host falls, the standby NFS VM configuration on PV1 is active. This standby VM start booting directly from the replicate ZFS disk, which Proxmox automate for Proxmox to a writable state. The NFF service then resume now being served from PV1. As we can see, the clear benefits is that our shared storage remain available even if the origin host of the NFF server falls, enabling true high availability for all other VMs that rely on this NFF. Why high availability is excellent for maintaining uptime during hardware or node failures, it doesn't protect against all data loss, such as data corruption, accidental deletion, or larger site-wide disaster. For comprehensive data protection, robust backups are essential. We integrate Proxmox backup server. We can call PBS into our environment. PBS is an enterprise-grade open-source backup solution specifically designed and optimized for Proxmox VE. As shown, our Proxmox VE host connect to the PBS server. VMs are packed and PBS store these backup efficiently as data truck. The key feature we utilize include incremental backups, meaning only trained data is safe after the initial full backup, and deduplicate, which significantly reduce storage space by storing unique data block. Only one. PBS also offer very verification to ensure backup integrity. Regular backup jobs were scheduled for our critical VMs through this dedicated PBS instance, ensuring we have ability to restore entire VMs or individual files where necessary. Now to illustrate how high availability works for our client VMs using this resilient AIRC server, I will show you a video demonstration. Okay, as you can see, currently VM 101 and VM 102 is running on PVE3. To simulate PVE3 falling, I will connect to itself and start the critical cluster service. Now PVE3 will become unresponsive to the cluster. It will now go through its process. It's wait for a timeout to confirm PVE3 is truly down, perform fencing if necessary, and then it will select a suitable online node from our gateway HA group, like PV1 or PV2, to restart VM 101 and VM 102. Okay, there we go. After about 1 minute, VM 101 and VM 102 is now starting up on PV1. As demonstrated in this video, the client VM will successfully restart on another node, maintaining service continuously. Thanks to Proxmox HA and our resilient storage. To conclude, this internship project has successfully resulted in the establishment for a Proxmox VE cluster with significantly enhanced resilience. We are implementing AIRC for self storage, and a key achievement for ensuring the high availability of the NFF server VM itself through ZFF replication, which effectively minimizes once or a critical single point of failure. This create a robust platform for data of activity by combining the HA and web server, Proxmox HA for client VMs, and reliable data protect with Proxmox backup server. The main learning for me have been the invaluable practical application for the high availability concept and a deeper understanding of the critical importance of identifying and mitigating any single point of failure within an IT service. Looking ahead, potential future work could involve the full automation of the web server fallback process, or perhaps exploring more advanced distributed storage solutions like Chef, or even greater scalability and resilience. Thank you very much for watching my presentation.